Hi, this video is going to show how to program one of three files that were sent from Skagit Technical School. And we're going to show the general architecture, the basic architecture of the system and how it compares to some other systems. Before I start programming, the most important thing to understand is that this software is actually running on the machine. Right? So conventionally you would program on a system kind of like this, on an offline computer, and then you would post-process your G codes and put them on the machine. With this system, we bypass all of that. If we were actually connected to a machine right now, I would press the X, I could actually jog the machine around. The machine would actually be moving right now. And the concept is basically you program your toolpath and then you press cycle start and the machine starts to run. And you can program your toolpath in a variety of ways. The most common is to import a step file or a variety of other CAD formats and then program your toolpath on it and then actually run it from the machine. So there were three files that were sent. There's the one that you see on the screen there, and then there's this one which is significantly more complicated. And then there's this one here which is kind of the level of complexity in between the other two. Okay, so for purposes of this demo, we're just going to show this file here. Okay, so the first thing you would do is basically set your zeros on your part wherever we decide we're going to set our zeros, and then start programming a toolpath. So we come over here to our toolbox, and then open up, and we'll insert a face mill to start. And I would select a 2.5 inch shell mill, something like that, and then we can select the top edge here, and you can see that it chains all the way around, and then hit OK. And there's a toolpath that it generates to machine that top surface. Of course, we can do things like change the cutting axis. We can change the step over, we'll make it 1/2 inch, which we'd probably not do. You'd probably leave it closer to 1 or 2. And then you can verify it with the toolpath simulation. So you see what the machine is going to do. And then whenever you're ready and you're comfortable, your zeros are set up and everything else is good, you press cycle start. And the machine, if we were connected, would actually be running right now. The tool would actually be moving to that location, and it would be cutting across that face and machining your part. So you can see the turnaround time is very fast. From the time you import your file, make a toolpath, and press cycle start, you're running in a matter of minutes or seconds even. Okay, so let's go ahead and stop that and just turn off the tool for now. And then we can just comment this face mill instruction out. And the next thing we want to do here is cut out this internal pocket. So we'll insert a pocket instruction and select, we'll do 3/8 short. Use a 3/8 flat bottom end mill to get in here and rough this all out. And we can just select a 3D face. We'll just go ahead and select this face down here. Then we refresh the toolpath, and there's our high-speed machining toolpath. Okay, so we can change a step over. We'll change this over to say 50 thou, something like that. And then again, you can just come over here to your toolpath simulation and kind of watch the tool go into the part, drag the slider to the right over here, and see it go through all the concentric arcs to pocket out this this internal pocket here, and then it's going to go around the perimeter for a cleanup cut. And all this is controllable with these options over here. So you have the cleanup amount, the type of pocket routine you want to perform, and those sorts of things. And one thing that's really great here is we don't have to insert our depths or have any dimensions, because we have all that information is contained in the step file, right? So we basically just select the face we want to cut down to, and it understands the adjacent face where it would start from, so up here, and it starts to spiral in from that location. Yeah, so it's a big benefit to work with 3D models. We can change some things if we want to change, like say the clearance. We want to add an extra 1 inch, or if we want to start the rapid height up 1/2 inch, it'll start to spiral now from a higher location. Okay, so let's go ahead and comment that out, and now we'll do some drilling and tapping on these holes here. So we just insert a drill and tap instruction. And we'll pick for our peck drill, we're going to pick this tool that I have labeled as drill number 1. And I'm not too sure what diameter it is for the to demonstrate the software. It's not really that important. We'll just go ahead and select that tool right there. Then for the tap tool, I'll select tool 11. And we can also center drill that before we peck drill and tap. We'll go ahead and leave that alone for right now. So now we're going to go through and just pick our edges here to represent each of these locations that we want to drill and tap. Okay. So now you can see it's going to basically go to each of these locations here, and it well, let's change our center drill tool here. We'll actually just make it the same drill as the drilling operation. So it's going to first center drill each of these locations and then change tools to our drilling tool, drill all of these locations out, and then tap each of these locations. And so we can simulate that again. You can see it's going to go through, and now it's going to actually do the big drilling operation to depth. And then it's going to tap each of these locations. Okay. Okay, and just to show one more important aspect of this interactive system, since we have knowledge of basically all the toolpaths here and the solid model, we can do things like comment out part of the drill and tap instruction. And of course, you see we've commented out the face mill and the pocket. So we can run just any individual part of our program much easier than if we were on, say, a G-code machine. Like, let's say you were doing this drill and tap operation and you got through the center drill and then the drill broke or something else was wrong. Typically, in conventional systems, you would have to restart the entire program over from the beginning and just kind of let it cut air or something like that. Whereas here, we can just comment out the center drill, and now we're just going to run the peck drill operation, where we can comment out both the center drill and the peck drill operation and just run the tapping program. We can also comment out individual locations. We have the 7 locations that we're going to cut. We can comment out, say, 4 of those and just leave these last 3 here. And then when we press cycle start, you'll see that the machine is going to just do those 3 locations. Show our tool here. It's doing the first location, and it's just going to do the tapping operation because we have the peck drill and the center drill commented out. So a lot of interactivity, and that's a big benefit to the system. Okay, hope that helps. Thanks. Bye.